Okay, guys. This is very important. I need you to listen to me. Are you listening? Are you listening? Okay, I'll tell you listening. So how do I say this?
Asteroid about to hit Earth. Plan B not included. How are you gonna survive?
Yeah. That's actually a thing. Go search it up. So let's see.
I'm not even searching.
What was it called again?
Click on it.
Wait, what's it called?
DART NASA mission to asteroid.
DART NASA mission
To asteroid.
asteroids.
Got the space.
Watching NASA. Okay, this one is it. Okay, you can go. Bye bye. This is a DART mission. Let's see. Wait, does this one have sound?
Sorry for that.
Okay, and this spacecraft is this some?
Oh, that's one live. Space! So, there's gonna be an asteroid the size of an Eiffel Tower hitting Earth. So, you know, like the dinosaurs got hit by an asteroid and then they all died. That's gonna happen to us. You can search it up. Like, boom! Like, boom, boom, boom! Like, details, type NASA DART mission to destroy asteroid. Also, there's no plan B, so I'm not sure we're gonna survive. Okay, there it is.
9, 8,
Side booster ignition.
6, 5, 4, 3,
Oh, that's so cool.
2, 1.
SpaceX.
Good evening. It's Tuesday, November 23rd, and on your screen is a live view of Falcon 9 as it awaits its 10:21 p.m. Pacific Time launch from Space Launch Complex 4 East at
so the
Vandenberg
asteroid's
Space
not
Force
hitting
Base.
it. It'll hit it
My name is
month.
Jesse Anderson. I'm a production and engineering manager on
basically,
Falcon 9
they're
here at
just testing
SpaceX.
to see if it's gonna
Welcome
hit
to our
the
webcast
asteroid or
coverage
not.
for the Double Asteroid
this
Redirection
is how it's
Test,
gonna
or
work. So
DART
the
mission,
asteroid is
managed by
coming,
NASA's
so
Launch
they're gonna
Services
send a
Program.
rocket
If
to
you ever
hit
saw
the
the movie
asteroid,
Armageddon
and
or
it's not
played
gonna destroy the
Asteroids as a
asteroid
kid,
or anything,
this
but
mission
it's
is for
gonna
you.
send the
DART is
asteroid
SpaceX's
another way
first
so it doesn't hit
interplanetary
Earth.
launch for
Get it?
NASA and the first planetary defense test to see if humanity can change the motion of an asteroid in space or stop it altogether. As part of NASA's larger planetary defense strategy, the DART mission will prove that a spacecraft can autonomously navigate to a target asteroid and intentionally collide with it, a method of
Siri,
asteroid deflection
Is
known
there
as
gonna be a
kinetic
giant
impact.
asteroid to hit Earth?
The target asteroid, which poses no threat to Earth, is the asteroid moonlet Dimorphos, which orbits a larger asteroid named Didymos. If all goes as planned, DART will direct itself to impact Dimorphos at roughly 15,000 miles per hour or 4 miles per second, which is 6 kilometers per second, just under a year from now, somewhere
I'll read it
between
to you.
September 26th and
You can
October
trust,
1st
you
of
can
2022.
Okay, here.
Scientists will use telescopic observations of the asteroids, images taken by an onboard camera, images of the DART impact event collected by an Italian space agency CubeSat, and data collected later by the European Space Agency's Hera mission to build a more accurate model and better prepare us to successfully defend the planet should a future asteroid impact threat ever be discovered. The DART mission is an awesome example of science fiction becoming reality, and the SpaceX team couldn't be more excited to be launching this payload to space. We will learn more about the DART mission later on in the broadcast, but first, let's take a closer look at the vehicle on your screen. Now, as many of you may know, on your screen is a live view of our Falcon 9 launch vehicle. Our two-stage liquid-fueled launch vehicle is in position at Space Launch Complex 4 East at Vandenberg Space Force Base. Today marks the 26th mission for SpaceX this year and 128th flight of a Falcon 9 vehicle overall. This is SpaceX's first flight-proven launch for NASA's Launch Services Program. This first-stage booster supported Sentinel-6A around the same time last November and took its second flight on a Starlink mission in May of this year. Now, if you're new to our webcast or unfamiliar with Falcon 9, what you see at the bottom two-thirds of the vehicle are SIP markings from its previous two. Drone ship, of course, I still love, and stage continues on its journey to orbit.
Okay, there.
The smaller the two asteroids. DART will hit the asteroid nearly head-on, delivering enough energy to leave an impact crater, but not enough to destroy the asteroid, eject it from its orbit around that larger asteroid, or noticeably change the pair's orbit about the Sun. Now, the second objective is to change the binary orbital period of Dimorphos. Now, the orbital period is the time it takes the smaller asteroid to circle the larger asteroid you can see here in the graphic. Currently, Dimorphos is in that original orbit. Scientists estimate the collision will shorten the smaller asteroid's orbital period by several minutes, placing it into that new blue orbit. Now, the third objective is to use ground-based telescope observations to measure the orbital period change before and after the impact. Telescopic observations in the weeks after impact will confirm that DART changed that orbital period of Dimorphos, and it'll reveal by how much. And then finally, the fourth objective is to measure the effects of the impact and the efficiency of that deflection. Now, choosing this binary asteroid target for the demonstration takes advantage of the fact that changes in that smaller asteroid's orbit around its larger partner can be more easily measured than the changes in a single asteroid's orbit around the Sun.
To ensure the best possible data capture, the DART mission is taking along some pretty cool technologies to help capture this demonstration test. On board the spacecraft is the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, also known as DRACO. Now, this is not to be confused with the Draco thrusters on SpaceX's Dragon spacecraft. DART's DRACO will provide real-time streaming images of the asteroid as it approaches impact. In addition to the onboard camera, the team is also flying a CubeSat from the Italian space agency known as LICIACube, which stands for Light Italian CubeSat for Imaging of Asteroids. This cube will be deployed from the DART spacecraft 10 days prior to impact with the asteroid. LICIACube will use its onboard propulsion system to alter its trajectory, offsetting so that it flies past Dimorphos approximately 3 minutes after the DART impact to capture the effects of the impact. Now, it's pretty incredible to think about what a mission like this could mean for the future of planetary defense. Now let's take a closer look at what the NASA team is hoping to achieve with the Double Asteroid Redirection Test mission.
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, that's kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life would I have thought I would take a couple $100 million.
Wait, pause the video. Okay. This is not my thinking. Anyone should make their own plans, but this is what I think. You should have a plan B, because if that rocket misses or does absolutely nothing to change the asteroid's orbit, you have a plan B. My plan B is to just go underground.
Spacecraft and crash it into an asteroid. My name is Michelle Chen.
I'm Lena Adams. My name is Kelly Fast.
I'm Andy Rifkin.
I'm Justina Sorovitz, and I help tell the story of the DART mission.
I'm a planetary defender.
And I study how the orbits of asteroids change after we hit them with spacecraft.
My job was primarily to make sure all the systems on the spacecraft work together.
The DART mission is NASA's first test of a planetary defense technique called kinetic impactor.
DART is the Double Asteroid Redirection Test.
It's just a spacecraft that is going to go and smack an asteroid.
The moonlit Dimorphos, which orbits the asteroid Didymos.
And see if we can change its trajectory just a little bit.
In order to show that we can deflect incoming asteroids if we need to.
DART will only be changing the period of the orbit of Dimorphos by a tiny amount. But in space, just a little bit is just enough to make an asteroid actually miss us in the event that an asteroid is discovered well ahead of time before it might impact Earth. Behind me, you see the spacecraft.
It's really cool to see it coming together in real life.
It is fantastic to see it in real life.
To see it turn from ideas into real pieces that are going to go into space.
The solar arrays will actually roll out to 28 feet in length.
Once the solar arrays are deployed, it's going to be the size of a school bus. As the solar array opens out, it's going to swing out in this direction. The asteroid's only 2 football fields in size.
We're flying at over 6 kilometers a second.
30 days out, we see 1 pixel on our field of view.
You can see Didymos and Dimorphos as 1 point of light.
About 4 hours out, our spacecraft becomes autonomous.
And then that's where everything gets really exciting.
You actually are seeing impact.
We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact, figuratively and literally. No DART! The dinosaurs are made completely extinct by an asteroid impact so many years ago. Here we are, we can actually do something about it. I think this is just wonderful.
Wait. The dinosaurs went extinct because of an asteroid. Same thing's happening to us. So the dinosaurs went extinct because of an asteroid. And humans could evolve because of that asteroid. Without that asteroid, we will not be existing because dinosaurs will rule over the world. So here's my theory. What if we die and then another species came and that species can only come because, like the dinosaurs, we get wiped out too? Just a theory, not real.
It's currently T-minus 4 minutes and counting. Everything continues to be go for launch. Spacecraft is transferred to internal power. On your screen, you can see the large structure next to Falcon 9. That's a strongback. Currently, the clamp arms have opened up, and you can see that the strongback has begun to retract away from the rocket. It's moving all the way back to a launch position about 77 degrees upright. Now, this is different from Falcon East Coast launches, where we move the strongback only 2 degrees, and then we retract it the rest of the way at liftoff. It's Slick 4. Once we get it back into position here in about another 40 seconds or so, we won't have to move it farther away at liftoff. Also, while we were watching the video, we have completed the fuel load on the first stage on time as expected, and we've begun chilling of the Merlin engines. Coming up on T-minus 3 minutes, everything continues to be go.
Stage 1 LOX load complete.
And we just heard that call out, LOX load complete. That is the first stage LOX loading being completed. Second stage will complete around T-minus 2 minutes. And Falcon 9 and DART teams continue to track no issues for launch. Weather is still looking great, as John mentioned. The range is ready to support, and SpaceX team is into orbit.
Okay, it's gonna go. This moment. So excited.
Eight, 7,
6,
5, 4,
it's gonna hit the
3,
asteroid.
2, 1,
I hope it does.
0. Mission. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission.
If it doesn't, we're dead.
Vehicles pitching downrange.
This is live. What? Yeah. I hope it hits it, otherwise we'd all die.
No, it's going to take 10 months. You're going to be watching for 10 months.
Okay, fine. It's not actually live.
Stage 1 chamber pressure is nominal.
T-plus 33 seconds. SpaceX launch engineers seeing a nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft. M1D engines about to begin throttling down.
Power and telemetry nominal.
We're throttled down. Avionics calls out good power on the vehicle.
Vehicle is supersonic.
This is so small. Okay, it's coming. It's gonna hit it. It's Is it gonna hit it? Is it gonna hit?
1,000 miles per hour.
Oh my god.
Max
They
Q.
duct tape the camera to the top of the
We've
ship.
gone supersonic. We're through the period of maximum dynamic pressure. The Merlin 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9. Everything continues to look good with the stage 1 trajectory.
Are we just gonna watch fire?
Yes. Okay, I'll skip a bit.
Invec chill has started.
Okay, there.
Invec ignition.
We've got successful stage separation. Second stage engine ignition now at full power on the Merlin engine. Next event coming up is going to be payload fairing jettison. On the left side, you can see the titanium grid fins on the first stage beginning to deploy as we get ready to bring the first stage back down to the drone ship. Of course, I Still Love You in the Pacific Ocean.
I still...
Getting ready now. There's
Fairing
the view
separation confirmed.
of the fairing.
Oh, there it goes.
And we've got deployment of the payload fairing, and now the DART spacecraft exposed to the vacuum of outer space. Now, we will be attempting to retrieve these new fairing halves with the help of our recovery vessel, NRC Quest.
Stage 2 on nominal trajectory.
Hold on, I'm looking at it.